Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name's Keith and I'm your host. Come on in. Let's see what our next video is all about. Alright, how about something new, huh? Take your hands off Buffy. Alright, today we have two pieces of fiberglass. These are tube shapes for stern tubes on marine vessels. This is going to be the main tube, and then this is just going to get cut and we're going to use the sleeve section of it to fatten one end of this. Alright, now this is rough and it's about 4-inch diameter, 4.5 on that one. And if we take and we hold this up, I'm going to rest that end on my compound and we're going to put that end at the chuck. Alright, we're going to be using this full length. We're going to set it up and machine the full length. Not the whole length of it, we're going to use the whole part of it, okay? The butt end of this is 2 foot past my lathe bed. So we're going to show you how we handle machining something that's longer than our bed and won't fit through the hole in the headstock. And this part here has got to be machined inside and outside. Alright, we're going to start, not in the lathe, we're going to start this project over in the K&T. So let's head on over to there. Okay, for right now I'm going to set the short tube out of the way. Alright, let's get the big tube located in our jig. Now this is the jig that we normally do our rudders with, and it's so that we can endo the rudder and keep the pintle in line with the upper stem. It comes in handy for a lot of other things, and it's going to come in handy today for stern tube boring. Alright, and we're going to guess about the middle of this, and we're going to use our sky hook here. Let's see how close we are. That was a good guess. Okay. Alright, this doesn't weigh a whole bunch, but when we do get set up and we're traveling, this is in line with our mill, and we'll let it hold the end of there. Keeps the wear off your ways on your table. Kind of been my practice since I've been there. Alright, and we'll go ahead and we'll find center here, and we're going to bring you in and show you a little more of what we got going on, because we've had to make some tooling to get this done. Okay, the first thing we do is we got to get this clamped down onto our jig, which is just basically a V shape, like a long 32-inch V block is what this kind of looks like. Alright, and we may rotate it here or there because this glass on the outside is really oddball. Our hold down clamps are Bessie clamps. They work real well. I have a pocket that's there's a pocket in here that I have for the clamp to go right inside this box tube. That was designed for a special rudder I used to do for True North boats. And for these long tubes, it really comes in handy as well. Okay, so in In reality, that mill can hold that whole thing, but you magnify the weight of that whole tube and magnify how far it's sticking out there. It's a lot of weight on the ways unnecessarily. All right. I always kind of just give it a general. When you're actually moving your mill around, you can actually tell if you got the weight or not, or if it is a problem. You can feel it in because you've run the machine on a regular basis. You know how your ways feel. All right, this is the basic setup. This jig automatically lines that up with the table. So now all we got to do is line up our work with our cutting head. This is the bearing that's going to get installed into here. Of course, we have another modification that we do to standard bearings and stuff like that to make them easily drawn out of the tube when they're ready to change out in 2 years. Average 2 years, 3 years pushing it. Bearings are rubber. They rot even in water. The same thing as tires and everything else in life made out of rubber. So this is a consumable item. Just reminding those that never change them and then have problems with their shafting. All right, back to the story here. So we're going to bore that. Well, this, good, it's still loose on here. Okay, this is my normal boring bar for doing my struts, rudders, and other things. And lots of, very rarely do I have to be longer than this. And the rigidity of this is controlled somewhat by the lead that I have wrapped around the shaft, and then I just have electrical tape on it. Sometimes you see different colors on it. Different videos through the past, you'll see all kinds of different color tape on this one bar here. All right, and I've had to repair the collet end of this holder right here with some silver solder once or twice because it wants to break out on there from the pressure and vibration and stuff like that. So we decided to go ahead and make us a bigger boring bar. I've been wanting to do this for a long time, and basically this is, I just took the design of this end, which has got a spanner nut here and a 12 thread per inch lead of thread, a clearance for it to slide into the slot here, and then a T-nut bottom basically is this, it's like a skinny T-nut. So I machined this bar here, and we're gonna use this bar, and I made, it only fits in here one way because your bit is gonna sit in here, and you only work that bit off of the direction of travel on your head. All right. And then the big nut comes down and seats in there like that. Now you'll see that as we're operating. You'll see it from the other side when I'm doing some setups and stuff like that. All right. So I definitely have got the travel now to do this. This bar sticks out here quite a ways. It's probably far superior now than this Chandler boring head. And I might also have to pull these two Allens that hold the gib tight because I've used them so much over the years. You really can't sock down on them tight because the Allen in the head of the bolt there is getting pretty rounded, and I don't want to totally strip them out in the head yet. So we're going to be testing theories and practical experience and this jig and how we normally go about boring out our rudders and other things that we've had in here. This isn't the first stern tube I've done. This is the first one with this large of a bearing. Okay, we stuck our indicator up here and we moved it around to get that alignment side to side, up and down, rough alignment, okay? Just so that we know that we're in the ballpark where we can start putting that in there. And then just staring down here, I can see that I have clearance here. It's touching here, and then it's not touching until it gets back about here. And that gap is probably like 60 thousandths, maybe a little bit better. So I know that this is bell mouth, or the material swedges out than here. See, this material calls out, and it's actually about 4 inches right there. and out here on the end here is 210 or so. So we're going to slide it. It looks like it's only maybe that much right there. We're going to slide off the end so that it comes down and resting more uniform with the rest of that pipe there, instead of being contact back here and it's bell mouth here. So you really have a lot of hollow in here, and you're holding the axis really offline. So it's not where it's at when you're machining, it's where it's at after you get done machining. We got this slid off the end here, only about a little shorter than 2 inches, and then I brought the indicator back in here. So we're sweeping it around, and we're looking at it pretty close to the outside of the top, and we're inside down at the bottom there. And when I first had that up on there, I was pretty close. I was, by eye, I was closer than that. All right, we're almost inside there. We're gonna just adjust it there. All right, and look at our handle here. We'll just bring this in a little closer, and okay, the ball of the indicator width around the outside there, we're pretty darn close. All right, now we'll just tip this up. Oh, we're already at its max there. One of these days we'll have to get a knob for this side, right? All right. We got it inside there now. All right. But we do need to tighten that up a little bit more here. Okay, now we're tight. All right, now we can, I want to angle that down a little bit. And we'll give it some motion there. All right, let's see what we got. This is really rough inside, so I'm just going to be going for a mean. All right, we're within about 5 thousandths variance. It's almost 10 thousandths wider than it is one way, the other way there. I am actually going to call that 0, and I'll lock down my table axis in and out, and we'll be free to run this in and out freely this way. Now what I'll do is a combination of by hand moving my table in the x-axis here, and how much tension I put on this, I will know that I'm gliding along in line with the table, and then I'm good to go. And then we're going to go ahead and start setting up the bore. We got the bar where we want it, and we've circled that around. Now we're going to go ahead and tighten our nut here. There we go. A couple little wrenches for that job. That's what I mean. This bar is not going to let go of this side of the slide, okay? This side of the slide may let go of that. All right, and we got the bar tight, and this is the set screws, or this is the keeper screws that actually tighten the on the gib here. They're gib screws basically for the slide here, and we're just going to lightly tension these up. We may have to pull these out of here. I've been meaning to do it for a long time. And then I'll have to go to the hardware store and match up the threads and then put them in and machine them, because they're shallow Allen's cap screws. All right. Now we're just going to go ahead and I'm going to feed this in just a little bit by hand here. Yeah, we got almost a full cut all the way around. All right. Now, this is going to make fiberglass dust. So I have to set up a vacuum system. Otherwise, fiberglass is going to be flying all over everywhere, and I don't want to breathe it, and I don't want to wear it. Okay, here we go. We got the phase converter noise, we have the K&T noise, and we have the vacuum sucking the end of the pipe. We have the vacuum in here, so we got air sucking in there. Okay, I put a dirty rag down here because this is just a waste of rag. There's going to be a little bit of powder on here, and then I can just take this and I can throw it away. Okay, the fiberglass is not your friend, not my friend. Okay, let's start. Okay, and we got kind of a coarse speed on this, one inch a minute here, so it's 12 inches long, so it's like a 12-minute cut. But we're just going to lightly skim this. We're happy with our 0. Okay, one thing that I didn't check, and I want to make sure before I actually start going in there, is how much material do we actually have to play with. Okay, the OD of our bearing is 3 1/8, and our first touch off and skim is about 3 inches 90 thousandths. That feels pretty uniform. I'm gonna go for it. Okay, we're just touching now. I'm just putting a mark here at the edge of my cable. I'll know when I get in there. 10 inches. It'll be somewhere around in there. And we'll make sure that we're a quarter, half an inch past it. By running the vacuum on the other side, you can see that you don't got too much. I see about 2, 3, 4, 5 speckles right there. Very, very clean. I'm liking, I can feel a little bit of the cut going on in the bar, but this thing is not singing or making noise, and the finish looks pretty darn good too. We're coming up to our mark right here. I'm going to let it go past it a little bit. Okay, now we're going to punch 0 into our DRO here. Okay, and now we're going to feed it out. Alright, and we're going to put it in neutral so we can swing it around and adjust it. And we're going to back this out so we can get measuring tools in here. And that's about as far as okay, I'm going to go ahead and get snap gauges because I want to check it with a little more accuracy than a pair of calipers. Okay, 3 inches, about 88. All right, so we're gonna feed it out a little bit. We got our indicator we like to use for this set up, and there's 0. We loosen up the gibs here, and we're at 3 inches, 88 thousandths, and we're going to 3 1/8. So I'm going to give it 15. That'll be 30 on there. So we should be just coming up underneath our dimension we're going to want by a couple thousandths, maybe 5. All right. Put it back in gear. And here we go. Okay, measures right on the money. There's a little bit of coarseness to that, but it's smooth. As smooth as machined glass can get there. Alright, we're going to take this out into it, do the other end, and then we're going to bring you in when we get over into the lathe and we get this set up in the lathe to do our machining on the outside, concentric with the inside for both ends. The first thing we're going to do is get our tailstock off of the lathe, and we're going to take this round diameter here, which matches our fiberglass tube roughly on the outside. Take our steady rest, set it up on the carriage, and we're going to adjust our steady rest for that diameter. And then we'll be able to put our steady rest back on the lathe back here at the farthest distance we can, so that the less chance of being off. You know, I mean, the greatest tolerances can be kept by holding that as far away from this end here as well. And then we're gonna chuck up on a small 3 jaw, because my jaws won't go inside the pipe that we bored, because we want to locate each end by the bores we machined. Now once we claim a steady rest surface on each end, then we'll be able to set it up and do the 2-foot long stretch on one end that's going to take the sleeve for the transom, or the keel section of the bearing support, where it goes out the back of the keel, I should say. All right. And we don't have to put it all the way down there. I don't think we're going to need the crane for anything, so I'm just going to put that back there. We'll be able to set the steady rest right in here after we have it set. Okay, top one, that'll adjust down. Okay, we lock these in. All right, we'll move the steady rest down at the end of the lathe. I'm gonna roll this pipe back because it's crowding me. Okay, here we go. All right, we're gonna put this down out of our way, and we'll probably have to open this up here. I have my 6-jaw, or my 6-inch 3-jaw, my 6-jaw. I don't have a 6-jaw here at the shop. Okay, so we'll have to open that up a little bit more. But it feels like something's in my jaw, so I'm going to go ahead and back this out. Okay, let's see if we're close now. Pretty close. Okay, going to be good enough there. Okay, I have a taller chuck wrench, works better in here. Let's see. All right, we're just gonna put that down for a minute. Not really grabbing on much there. Okay, what we're doing here more than anything else, we're going to mark this area where the steady rest is. And now we can endo it, and we know where we're going to skim for a steady rest. That'll be the first thing, is actually holding a 3-jaw to the bore, skimming the steady rest, endoing it, skimming the steady rest, and then we know that we're going to have a good rest spot that's actually turning without having the texture of the fiberglass wrapping on the outside here, because it is irregular. Okay, we're going to get a couple zip ties to hold this on here, and we're just going as slow as possible, but you can see that we're only cutting about a quarter of the way around for our first cut. I don't want to create too much friction. I'll be a cheap bastard. I don't want to. I don't want to waste a zip tie, right? That's a little coarse. That's a little better. Okay. We should only need to turn that steady rest area for this area right here. And this will be the end that we machine for the sleeve. So I'll unchuck this and we're going to 180 this. That sounds a lot better. Okay, this end actually runs out after they put the sleeve on this end. I can go ahead and touch this end up a little bit because it's almost a 1/4 inch out. I should have. Well, I do have the facing head. I could put it over there and do a quick face on it. All right, let's mark off 2 foot here, and we're going to give it a clean skim, 2 foot long. That's some old tape. Okay, let's go for it. All right, we fed it in until we were making a cut all the way around, and you can see that it's just barely cutting on one side and then taking the big chunks off the other side. We don't know if it's going to go all the way clean like that, but it more than likely will, because it looks like this is running truer down here at this end. Then we'll call that our diameter, and then we'll finish boring out the sleeve over there. I have to laugh. I'm looking here in my Note 4 that I'm using to monitor my Osmos camera. The face is separating from the phone itself, so I don't know how long that's going to last. I'm going to have to find my other old Note 4. Anyhow, we're happy with our fit. There is a little discrepancy of the two bores lining up with each other, but I've got it to go about here. I've tapped it on with the rubber mallet, and I've tapped it back off, so it's going to be a good application. They're going to sweat it on wet, and it's close. That's what we want. And then after that, then I'll come back and we'll get some more machining done on it, but they'll be able to put it in line and start planning its bore through the hull and the bulkhead to create its supports. And then I'll do my bit there, and they'll get set screws to hold the bearings. I'll thread the bearings, and we'll get this job done. That's pretty much how I go about machining glass tubes to fit for the propulsion needs in vessels. All right. Till next time, get her done.